Welcome to the New York Bioforce program. We're so excited to have you joining us this summer and can't wait to teach you more about research in the life sciences. Over the next few weeks, we'll be teaching you some of the essential skills you'll need to be successful in research. This video is an important introduction to the basics, but we'll be covering some of the topics more in depth later on. As you start your journey in research, you'll notice differences in the way scientists speak. A lot of the words you'll see may look familiar to you, but have different or narrower definitions than you're used to. Throughout our lessons, we'll be introducing you to new terms or explaining what specific words mean in science. Pay attention to this as it will help you think like a scientist. You probably remember learning about the scientific method when you were younger, and graduate and professional level research follows the same steps. Throughout the summer, we'll be showing you how to apply each step to a high-level thinking and study design. But let's get started with an overview. All research starts with a central question that we're going to try to answer. The more specific the question, the easier it will be to devise a plan to answer it. It's okay to start with a very general area of interest and narrow the focus as you conduct your background research, which is the next step. This step is one of the most important in high-level research. Instead of finding a few sources on a topic, a good researcher will sometimes find 100. These sources will come in the form of scientific literature. These are papers that have been written by other scientists about their work and published in scientific journals. A good researcher will read as many important papers as they can find that relate to their subject area, which lets them build off past work to create a cohesive research plan that will address a central question most effectively. This step doesn't stop when a scientist has devised a research plan. Instead, it continues throughout the duration of the experiment to let a researcher stay up to date on new developments, make adjustments to protocols, and understand unexpected results. This may seem overwhelming, but we'll prepare you to search for and make sense of these papers later on. Once a scientist has thoroughly researched an area of interest, they can narrow their focus and devise a plan to address their central question. Hypotheses can help them do this. They can be written for specific experiments or for projects as a whole, but either way they let the scientist plan exactly what steps they need to follow and what they expect the outcome of each step to be. Experiment outcomes may not always support the hypothesis, but that's okay. Sometimes this disagreement can help us learn more or tell us when we need to go back and do some more reading. After creating a research plan, scientists carry it out in the experimentation step. This step can include carrying out a series of experiments in a wet lab, programming a computational model, or collecting data from other sources like surveys of study participants. Whatever form it takes, the main purpose of this step is to collect data that can be analyzed later. An important tenet of high-level research is that the results are reproducible. This means that all work should closely follow written protocols, and everything should be correctly documented in a lab notebook. We'll tell you more about how to do this later on. Once data has been collected, it has to be analyzed so we can make sense of it. There are many tools that can be used to do this, including Excel and coding programs like Python or R. We will cover the basics of these later in the summer. The steps for data analysis must also be carefully documented and should be selected so as to avoid misrepresentation of the data. The last step in the scientific method is reporting. Just as in the beginning of our research plan we relied on other scientists' work to build off of, future scientists will rely on and build off of your work. By reporting your findings, you help make future research possible. We'll keep coming back to the scientific method throughout the summer as an important basis of conducting high-level research.